All right. Hello. Happy Friday, everyone. It is Friday. I almost said February. November 19th. Where's February? November 19th, 2021. We are talking about Han buying cartons of chocolate milk, and each carton contains 5/8 of a liter. Would you like to share?
Nice.
No, not you, her. It's okay.
I did 4 times 5 equals 28.
Let's talk about this right here first. Where did the 4 come from? It's yours.
He bought 4 cartons of chocolate milk.
4 cartons of chocolate milk. Where did the 5/8 come from?
He bought, they each came 5/8.
The cartons contain 5/8 in each one. Where did this time symbol come from? Other than you just knew that's what I was talking about.
That we have to find how many pages.
Where there's a group,
It has each in it.
has the word each. You knew that. The word each, we know, very often is going to give us this time symbol. Tell me your value again. So this is our expression, right? What's our value here? 28. 28. Very nicely done. Raise your hand if you got 4 times 5/8 equals 28. That's what you should have had on your paper. Very nicely done. Are you guys doing a good job following the directions on the banner? Is that working out okay?
Mm-hmm.
Do you have a tab for the lesson pulled up already?
Yep. Yeah.
Awesome.
Already done it.
Fractions as sums. We have been talking about fractions, multiplying whole numbers and fractions. Today we're going to talk about fractions and sums. What does sum and sums mean? What does that mean? Sums, fractions as sums. What do you think we're going to be doing?
Answers to addition.
Ooh, what's this? This here? This word here?
Our answers to addition or subtraction.
Not subtraction, just addition. Answers to addition problems. Very good. Someone in the last class said the value of an addition problem. Is that true?
Mm-hmm.
The value of an addition problem?
Yes.
I like that term much better. And the word answer is not wrong, but I just like value. It just makes us sound so much more mature and proper and fancy. Like we need to, fix up our bow tie. So let's write fractions as sums, shall we?
Yes, we shall.
First of all, let's count by 3/4. If we're going to count by 3/4, we're going to start with, and we're going to count by, let's go. Thank you.
6 fours, 9 fours, 12 fours, 18, 15.
15 fours, good. 18 fours.
44.
What?
23 fours.
33 fours.
36 fours. 39 fours. 41 fours. 42 fours. 45 fours. 48 fours. 51.
That's good enough. We went far enough.
Wait.
So, what pattern do you see here? What patterns do you see? Annabelle?
That I see that when you do it to the top, like the 34th one, and the 34th, and it's 36, and the 39 always go to the top one too.
You're noticing this here?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay.
So this would be 48. The next would be 51, 54, 57, 60. What would be down here? 63.
66, 69, 62.
What? 72, 75, 78, 81,
84,
7, 90, 93. So we would have 3, 33, 63 was first, and then 93. Interesting. Interesting, my darling. You're the first one to notice that today. I did that intentionally. No one noticed it except you. Anybody else in here notice that? Pretty cool, huh? Okay. There are so many other amazing things to notice. This is one of the coolest lists we have ever made. There are so many other cool things to notice. What else do you notice? What do you notice, Landon?
You kept the 4
Why did I keep the 4, Landon?
because you always keep the 4.
I always keep the denominator. Good. Why does the denominator not change, Landon? Why do we keep it? Because, Landon, this here went from 3 to 6. Why didn't this go from 4 to 8? Why did we not keep we changed the numerator. Why did we not keep the denominator?
Because it's the number that we have. Because it is the number we have.
Well, the denominator is the total amount of equal parts. Why does that denominator stay the same? Tucker, explain it to Landon.
I have a different one.
I want someone to explain to Landon why that denominator does not change. Don't talk to me, talk to him.
It stays the same because we're counting by 3/4, so only the numerator will go up.
Why? Annabelle, tell Landon. Don't tell me. I already know.
It's because
That's how many equal parts we have in the whole. Landon, we're counting by fourths. This is a fourth right here. 1. Landon, this is a fourth. This is a fourth. And this is a fourth. And so we're counting by 3/4 on in our number. This is the number counting by fourths. So yes, Landon, very nicely done. The denominator stays the same. What else do you notice?
Can I go up there and show you?
Sure.
Oh, I see that if you do this, you just gotta multiply it by 10. Then you do that, then you multiply it by 10. That makes 66 because you did this 2 times.
But it's not 66, it's 63. 3, 33, 63, 93.
I know I just saw that.
Yeah, I want to just talk about these numbers we have up here. Anna, what do you got?
The numerator is counted by 3s.
The numerator is counting by 3s. And when we count by 3s, what are we doing? When we count by 3s, what are we doing? Anna? What's that? What else is that called? Listing multiples of 3. And when you list multiples of 3, you're going to start with 3 and count by
3.
Very good. Where is the first time that we find a fraction in our list that is equivalent to a whole number of some kind. Cole? Which one? Think about what I'm saying. Okay. Raise your hand if in this class you like to change improper fractions into mixed numbers. Hands all over town. Which one? Because this is a fraction, correct? A regular fraction. Now, right away, we have an improper fraction, right? Which means this one is greater than one whole thing. Which one of these fractions is just a whole number? It's not a mixed fraction, a mixed number. It's a whole number. 1, 2, 3, 4, 5, 6, or 7. It's not 5 and 4, 1/4. It's just a whole number. Oh, I love the thinking. Gabe?
24 fourths.
Why do you say that about 24 fourths? Speak to me your reasoning, Gabe.
Well, I've got two reasons for the 10
Just tell it all to me.
and the fourths, but I know that 5 times 4 equals 20, and if you add just 4 to that, 24. So that would be
And
4 times 6.
so how many holes is this then?
6.
Huh. So if I have 6 apples and I cut those apples, each of them into 4 pieces, that's going to give me 24 fourths. Is that what you're saying? You are correct, my good sir. Everybody give Gabe 2 big claps. Good job, Gabe. What's another one that's a whole number? Tucker?
The 4 because it's a whole. It's
The 4.
yeah, because it's a whole number. It's
What's a whole number?
the 4 under it. Under the.
That's a denominator.
That's the denominator. Be kind. You're right, but speak with kindness.
Okay.
That's the denominator. That's part of the fraction.
Oh, I thought like it was whole because there's like 4 parts, so I thought it was just whole.
Chloe?
The 12 parts?
The 12 fourths, she says. Why, Chloe?
Because 4 plus 8 equals is 4 plus 4 is 8, and 8 plus 4 equals 12.
4. Okay.
12.
12. Huh. Interesting. You are right, Chloe. Give Chloe 3 big claps. Good job. What else?
48 fourths.
And how many holes is this? You're going out of order, making it hard on yourself.
Yeah.
Yeah, he says. Yeah.
Actually, I found an easier one. 36 fourths.
Oh, you want to do 36 first? Look, he wants to do them. He just wants to do them all.
Yes.
How many holes is this?
That's
Brentley, let Brentley have some have a turn.
7.
24, 28. What we count by?
4.
9.
Who can figure out how many holes 48/4 is by using a pattern of something else we've already written up there? There's another. I told you this is one of the coolest lists we ever made. There's a pattern up there. What's the hole? How many holes is 48/4, Emma? 12/4. So let me show you something here. So 12/4 equals 3 whole things. The reason for that is if we draw fourths and we color in 12, we colored in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12/4, which is 3 whole circles. We cut the circles into fourths. We have 12 of them. That's 3 whole things. So 12/4 equals 3. 24/4 equals 6. 36/4 equals 9. And 48/4 equals 12. What do you notice about this list here in orange? What do you see here? What do you see, Izzy?
I see that it's counting by threes. 3, 6, 9, 12.
Uh-huh. And what were our numerators counting by?
Fours.
Huh? Our
Fours.
numerators?
I mean threes.
Yeah, our original numerators were counting by 3s. That's right. And so, what else do you notice here? Bobby?
That every one, like 1, 2, then 3, 4.
Tell me more.
On the it's just counting side. Wait, it's counting by 2s.
In where? Where? In the ones place? 2, 4, 6, 8. And what's it doing in the tens place? Chloe, what's it doing in the tens place? Or yeah.
It's counting by 1s.
Counting by 1s. Someone in every single class has said that the ones place is counting by 2s and the tens place is counting by 1s. Which would mean, could we put, what would the next one be?
Yeah.
What would the next fraction be then?
49. Wait, no. 59.
50. Chloe?
10. Wait. 60.
Cole? Gabe?
54. Because 8.
Counting by 2s.
Not 54.
2,
I meant 52.
No. 2, 4, 6, 8, 10, 50. 1, 2, 3, 4. 54th equals how many holes? 15 holes. We could keep doing that.
Yeah.
But before we do that, may I take a moment to teach you some 5th grade math?
Yes.
Would you mind?
Yeah, sure. Wow.
Yes, sir.
What do you know what this line means?
No.
Fraction. That's what a 4th grader would say.
Yeah.
That's what a 4th grader would say. What would a 5th grader say? What does that yellow line mean? Why don't you? No, that's what a 4th grader would say. Why don't you look at these numbers here? See if you can develop some sort of a relationship between those 3 numbers. What's the relationship you notice?
It's 4 groups of 3 equals 12.
Huh.
And 3 groups of 4 equals 12.
Which when you're saying that, you're saying times, right?
Yes.
So 4 times 3 equals 12. And 4 times 3 equals 12. And 3 times 4 equals 12. Correct?
Yeah.
Is this a symbol for multiplication? No? What would it be a symbol for? What's the opposite of multiplication?
Subtraction.
Division. This line here is the same thing as saying this. 24 divided by 4 equals 6. 36 divided by 4 equals 9. 48 divided by 4 equals 12. 50 divided by 4 equals 15. You see what I'm saying? That's not right. That's not right. It's not 50. Because these aren't counting up by 2. It's not 48 to 50. They're counting up by from 12 to 24 to 36 to 48. They're counting up by how many?
12.
12.
That's why I raised my hand.
Oh, sorry. It's supposed to be 60.
Bobby got it right then.
So Bobby was right all along. Everybody give Bobby 3 big claps. Everybody give Bobby a whoop, 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 whoop. Everybody give Bobby a, we knew you were right, man.
We knew you were right,
man. Hey, Bobby, I'm sorry. You forgive me? Okay. 60 divided by 4 equals 15. Okay, what else did I want to say about this? I forget. I said it all. Which of these fractions are equivalent to whole numbers? 3, 6, 9, 12. To what whole numbers are they equivalent? We labeled those. Why do you think these patterns are happening? Why do you think these patterns are happening? We're counting by 3/4, and we're starting with 3/4. So if we always count by the same number, is there going to be some sort of a pattern? If we count by 5s, then we get 5, 10, 15, 20, 25, 30. You get a pattern. We count by 3s, we get a pattern. Obviously, if we count by 3/4, we get a pattern. I told you this is one of the coolest lists we ever made. All right. Make your classwork line on your Cactus Notebook, please. We're going to be working in those today. All right. So, what is your favorite soup? Favorite soup, Emma? Chicken noodle. Who else's favorite soup is chicken noodle soup? I can't eat the noodles, so I eat chicken and rice, but it's just as good, trust me. What is somebody else's favorite soup that's not chicken noodle? Potato soup. You're the first person all day to say potato soup. Who else loves potato soup? Oh, I love it.
I never knew
Something
that.
else? Another one?
Tomato.
Tomato. Grilled cheese?
Yes.
Obviously. Hello. It has to have grilled cheese.
Yeah.
No grilled cheese?
What?
Somebody's not making it right then. I'll have to come and make you a grilled cheese.
What?
What is in your favorite soup? We've been on this ingredient kick lately, haven't we?
Yeah.
Yesterday we talked about the banana bread. Today, obviously, we're talking about soup. Give me one ingredient from your favorite soup. Tomatoes. Potatoes. Egg. In soup?
Ew.
It makes sense.
I don't think there's eggs in soup.
That's what it's called.
Mushrooms.
Mushrooms?
Mushroom soup.
Love mushrooms.
Ew.
Potato.
Is it
Milk.
mushroom soup? Have you
Chicken.
ever heard of it? I've literally tried soup with mushrooms.
Sometimes I put cabbage.
Cabbage.
If it's like
Not bad. It's actually.
All right, so everybody close your eyes. Think about your favorite soup and that you were going to write the recipe for your favorite soup. What would your recipe say? What would be in your soup? You would need broth. How much would you need, do you think? Do you need mushrooms or cabbage or celery or carrots or onions? Do you need noodles? Do you need water? Do you need eggs? I don't know if soup has eggs, but it might. What do you need and how much do you need? All right, now we're going to look at a recipe for barley soup. You can open your eyes. We're going to look at a recipe for barley soup. Someone in Lynn's family wrote the amounts in the recipe in fourths to make measuring easier. Remember yesterday when we talked about banana bread? And the banana bread was like 2/3 here, 5/8 here, 4/3 there. It was all kinds of different denominators.
Yeah.
Wouldn't it be nice if you could just use one measuring cup for the whole thing?
Yes.
That is what Lynn's family did. So on your screen, you should have the lesson with your shoulder partner. So I want you to go over there. I want you to go back there. Yes, you need your Chromebook and your notebook and your pencil. You're going back with Tucker. And so with your shoulder partner, one person needs to have the recipe up and the other person needs to have the instructions. It doesn't matter who, just as long as one of you have the recipe pulled up and the other one has the instructions. Now, for your Cactus Notebook, here is your page. Ladies and gentlemen, go ahead. Here's your page. Remember on the left-hand side, you have that pink or red line, right? You already have your classwork line here like this. On the left-hand side of the pink line, I want you to write B for barley, and then I want you to skip a line. Then I want you to write C for celery, skip a line. A for carrots, skip a line. O for onions, skip a line. And then VB for vegetable broth. And excuse me, I got the hiccups. I want you to write those abbreviations B, C, CA, O, and VB.
I can't see the last.
Check your partner to make sure your partner has what your check with your partner. Check your partner's paper to make sure your partner has what they need.
Why is there BB?
Let me see. And then B. I did it right now. Yes. No extra A. It's B, C, C, A, O, B.
Okay. Oh, it's fine. It's fine. One's for celery and one for carrots. It's fine. Now, I want you to take and draw one line down the middle of your paper. Make sure it's pretty much in the middle because you are going to need a lot of space for each one of these. Okay. All right. Now, let's read. So one of you has the recipe pulled up and one of you has the directions, right? The question. Yeah? Okay. So, Lynn has only one measuring cup that measures 1/4. Show how Lynn could use the cup to measure the right amount of ingredients. So, picture this in your mind. Lynn is using barley, celery, carrots, onions, and broth, but the only measuring cup she has is the 1/4 of a cup. So, how much barley does she need? Look at your recipe. How much barley does she need, Bobby? 3/4. And if she only has the 1/4 measuring cup, what? She'd have to do it 3 times, and we're going to write that like this. We're going to write it right like that. You should write this on the side of your notebook next to the B. Nope, on this side. Yep. Next to the B, 1/4 plus 1/4 plus 1/4. 3/4, because the 4th measuring cup's all she got. All she got? Really? All she has. Wow. Sorry. That was really bad grammar. Celery. How much celery does she need? How much celery does she need, Dominic? 5/4. She only has the 1/4 measuring cup. So how many times is she going to have to scoop for celery? 5 scoops for celery. So 1/4. How many times am I going to write this?
5.
Right. That's right. 5/4 celery. Thumbs up when you're finished. How many carrots? How much carrots? How much carrots does she need? Brentley.
6/4.
Huh?
6/4.
6/4, and she's only got the 1 cup. So how many times is she going to have to scoop?
6 times.
6 times. How many times do you want me to write this fraction?
6 times.
1, 2, 3, 4, 5, 6. 6/4. 6/4 carrots. The next one's the hard one. Check on your partner. Make sure your partner's good. Make sure your partner's good. We got barley, celery, and carrots. Check on your partner. Make sure your partner's caught up where they're supposed to be. You're right. Why? Do you agree with him? Why?
If you have 4, you only have 1/4 of the cup right here. That's 1/4. And then you add 4 times, and then it equals a whole.
Because 4/4 equals a whole, right? Logan, how many onions are there?
A whole.
1 whole thing. She only has the 4th measuring cup, so how many does she need?
4 times.
4/4, because 4/4 equals 1 whole. Good job, Logan. And the last one's the hardest one of all.
Not for me.
Vegetable broth. How much is it?
2 1/4 cups.
2 1/4. So how many fourths does she need? 2 1/4.
8, 9, 8.
Talk to your table. How much does she need? Don't just say the answer. Say why. Explain yourselves.
Because 2/4. 2/4. 2/4 would be 8, and then we have 1/4.
Yeah.
Why do you agree? It's true to write 9.
What did you say? All right, Chloe, did you figure it out?
Yeah.
What was it?
9.
Why 9?
Because, so we have 1 whole, which is 8. 8 equals 2. 4 plus 4 equals 8, and then 8 plus 1 equals 9 because
1, 2, 3, 4, 5, 6, 7, 8, 9. So you're saying that 4 of these makes 1 whole. And then 1, 2, 3, 4 makes 2, the second whole. And then you have your 1/4 remaining, right? Who agrees with Chloe? She is right. 9/4. Good job. Now you're on this side of your page of the line that you drew. You're going to go to the other side of the line that you drew. And on that side of the line that you drew, we're going to talk now. Lynn has, she found a 3/4 cup measuring cup. So now she has a 3/4 cup and a 1/4 cup. What can she do for barley now that she has a 3/4 cup? She could just use 1 scoop of the 3/4, right? Wouldn't that be nice for her to save her some time? And then what could she do for celery? Write 3/4. So right here on the second half of your barley spot, I want you to write 3/4. Yep, that's it right there. Yep. Check on your partner and see how your partner's paper looks. Well, she has a 3/4 and a 1/4. So I heard a student say we can't do 5/4 because now she's got the 3/4 and she'd have to have 6. Right, but she's got the 3/4 and the 1/4 cup. So what could she do?
Do 1 scoop of the 3/4 and 2 scoops of the 1/4.
1 scoop of the 3/4, 2 scoops of the 1/4 would get her 5/4, right?
Yeah.
Work with your shoulder partner to finish the last 3: carrots, onions, and broth. I'll be around to check and see how it's going.
So 1 cup of chopped onions. She could do
Done.
for carrots. I did 3/4 plus 3.
Class is over in like 2 seconds. Go. Just go.
What are you doing?
For onions, she could do 1. For onions, it's just 1 3/4 and then plus 1/4. And then this one she can do.
Did you get it? Did you get done?
No.
No? Well, let's finish it together real quick. You had a few minutes. Carrots, what'd you get for carrots? What'd you have for carrots, Cameron? 3/4 plus 3/4. Did anybody have anything different? Can you do it that way? Sure. What do you got for onions?
3/4 plus 1/4.
3/4 plus 1/4. And for vegetable broth, this is going to be the biggest opportunity for variation. Annabelle?
3 plus 3/4 plus 3/4.
3, 6, 9, 4. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, yeah, that's right. 3, 6, 9. Very good. So let's see if we can talk about this real quick. This slide right here. Can we just out loud together, you guys can just sit your pencils down. Can we use different combinations of fifths to make a sum of 9/5? What different things could you use here to make 9/5 if you had the freedom to use whatever you wanted? But you got to fill in every one of these lines. So you got 1, 2, 3, 4, 5 different things.
So, go up for 2,
2/5.
then 1/5, 1/5, 1/5, 1/5.
That's 2, 3, 4, 5, 6. You have 2, 3, 4, 5 fifths. How many more fifths do you need to make 9/5?
4/5.
Good job. That's what we would put there. Good. What are we going to do for this one? Anybody got an idea? Bobby?
You can do 1/5. Wait, no. 3/5. 1/5.
Yes. Good job. Good. Who wants to do the next one? Izzy?
We could do 5/5 and then 2/5 and 2/5.
Very good. And the last one.
5/5 and 4/5.
Very good. Oh, whoops.
No.
5/5 and 4/5. Very good. Do you see how we can use different combinations of fractions to make these whole numbers here?
Yes.
We'll talk more about this on our review slide tomorrow. Let's load up and sanitize. Thank you guys very much. Excellent work today.